Good morning, everyone.
Good morning, ma'am.
Okay, so we will want to discuss the properties of directional derivative. Is it okay? So let us start with the properties of a directional derivative. Whatever I told you the homework that we will discuss in my lecture. Actually, this lecture was not planned. Sir urgently messaged me at 10:30, so I am conducting this lecture. So let us start with our properties of a directional derivative. Okay, what are the properties of directional derivative that we will see here in the starting one? Firstly, we are provided that let f and g be the real valued function. Let f and g be the real valued functions. So we are provided with the two real valued functions defined on E3. That means f, g are real valued functions defined on E3 space, and let Vp and Wp are tangent vector on E3. Let Vp, Wp are the tangent vectors on E3. That means they are tangent vectors in E3 space. Next, we are provided that A and B are the real numbers. Then we have to prove some properties. I will write all the four properties, then we will prove one by one. Okay? Then show that or prove that. Then prove that. Yes, what we want to prove is we have to start with the first one is A and B. We are provided they are scalars. So we have to prove that AVP plus BWP. That means we know that if VP and WP are tangent vector, their scalar multiplication and vector addition. With the help of these two property, we know that the whatever may be their linear combination is again a tangent vector. Is it okay? So what we have to prove, directional derivative function f on this tangent vector AVP plus BWP is equals to APPF plus B WPF. Be very careful about how to pronounce it. This is what a square bracket, so that's why it is called a directional derivative. Okay, directional derivative function f in the direction of AVP plus BWP is equals to A times VPF plus B times WPF. Okay. Second one,
Ma'am, your voice is little loud.
yes, what you said?
Your voice is little loud, ma'am.
Loud. Okay. Is it okay now?
Yes, ma'am.
Okay. Yes, everyone able to hear me? खूप
Yes,
जास्त
ma'am.
आहे खूप कमी आहे.
Yes, ma'am.
Okay, ठीक आहे. So let us start with that. What we have to say, this property we call linearity in f and g. Linear in f and g. That means if f is linearity in a tangent vector vp and wp. Sorry, actually these are vp and wp are the two different tangent vector, and we are going to find out the directional derivative function f on the linear combination of these two tangent vectors. So which will be resultant is AVPF plus VWP. So it is called, this property is called linearity in tangent vector VP and WP. What is the second property? We have two functions f and g instead of only one function, and a tangent vector VP and AF plus BG, which is equals to A, what we call it is VPF plus BVPG. Okay. So this property we call it is linearity in f and g. That means f and g are the two real valued functions, and vp is a tangent vector. So this is what a directional derivative of af plus bg in the direction of a tangent vector vp is equals to a times vpf plus b times vpg. Okay. The third property which we want to prove is Lebanese rule, that is multiplication 1, that is VP F into G, product of these two. So it is written as G of P, that means G as it is. We want to find out the directional derivative of a function F. It is very similar to whatever we have seen for the ordinary derivative. And then F as it is, then we find the derivative of function G. Okay, getting all the properties, what is given to us and what we want to prove. Hello.
Yes, ma'am.
Okay, let us start with the proof. What we want to do in the proof? First, we have to prove the first property, that is linearity in VP and WP. What is given to us? F and G are real valued function, VP and WP are tangent vector, A and B are a scalar. Okay. So should I start with the first property if you don't have a doubt about what is given in the statement? So let us start with this proof. We know the definition. What is the definition of a directional derivative function f at a point p in the direction of v is given by the initial rate of change of a function f at a point p in the direction of a tangent vector v. Or in another way, it is defined as what it is defined, summation over I vi dou f by dou xi, right, at a point p. Okay. After calculating all this, we have to evaluate the value at a point P. Everyone remember we have solved the two example with the help of this one, that is definition itself, and we have proved the same example have the same answer with the help of a formula itself. आठवतंय का सगळ्यांना?
Yes, ma'am.
Yes, ma'am.
Okay, so let us start with first property. What is given in the first property? AVP plus BWP. So let us start with this one. Okay, so we want to prove it is equals to AVPF plus BWPF. Okay, so what is given to us? V is equal to, we will have some coordinates as V1, V2, V3. W will also have some coordinates as W1, W2, W3, correct? As they are tangent vector, they will have some coordinates, correct? So how I will write AVP plus BWP? I can write this as AV1 plus, okay, let me write in detail this as AVP plus BWP is written as A times. This is what V1, V2, V3 plus B times W1, W2, W3. Then what is the resultant? AV1 BW1 plus next is AV2 plus BWP. Next AV3 plus BW3. Correct? Now using the formula 1, what we will write this as a formula 1. What is this formula? This is a formula for a directional derivative function f in the direction of a tangent vector VP. Okay, using the formula 1, we can write, okay, here what is a change? Here in the formula we have only one tangent vector VP, but here we have AVP plus BWP evaluated on a function f. Okay, getting what is a change?
Yes, ma'am.
Instead of having one tangent vector, here it is a linear combination of a tangent vector. So we can write the formula as, so resultant of this one is equal to, I can write this as AVP plus BWP directional derivative function f in the direction of this tangent vector can be written with the help of this formula. Now instead of VI, here we have a combination AVI plus BWI. इसको हम linear combination में लिख सकते हैं ना, AVI plus BWI, correct? So I can write this as summation over I AVI plus BWI. Any doubt for this one?
No, ma'am.
No, ma'am.
Okay. Now next is what your function f is saying here. We have to evaluate the derivative of a function f in the direction of a tangent vector vp. So that's why we have written summation over I vi dou f by dou xi. Now instead of that we have a vi plus bwi. Here as it is asnar hai dou f by dou xi. See now what is the change? Here it is vi dou f by dou xi. Here it is a vi plus bwi dou f by dou xi evaluated at a point P. Getting the change?
Yes,
How we have to write the formula with the help of a given formula. Any doubt for this one? See, if you are having a doubt, you can ask at any step, because if you are clear with the basic concept, then only you can understand in the next lecture what we are going to study. Because for the any paper or at least for the differential geometry, you should know what is there in the background. Because if you go for the paper of ADM and all, you no need to have to remember any chapter, right? Okay, ADM में सभी 4 chapter different है. One is graph theory, another one is combinations, permutations, and then it is lattice theory. But here in the paper like algebra 2, real 2, in the paper like we have functional analysis, you should know whatever there in the background. Okay, जहाँ पे हमने study किया है जो भी basic points, so we should know that. So if you have a doubt, you can ask at this step only. क्या चेंज है समझ में आया सबके? यहाँ पे चेंज क्या है? ए वी पी प्लस बी डब्ल्यू पी. यहाँ पे क्या था? सिर्फ वी पी. यहाँ पे डायरेक्शनल डेरिवेटिव फंक्शन एफ. हियर ऑल्सो वी हैव डायरेक्शनल डेरिवेटिव फंक्शन एफ. हियर इट इज समेशन ओवर वी आई, बट यहाँ पे चेंज है इसलिए हमने क्या लिया यहाँ पे? ए वी आई प्लस बी डब्ल्यू आई एंड डो एफ बाय डो एक्स आई एज इट इज. ओके. Okay, let us start with the proof. What we have to do now? Now the summation we have to separate and we will see the change. What we will happen? ABI dou F ABI dou F by dou XI at a point P plus next is summation over I BWI dou F by dou XI at a point P. Is it okay? Whether I have evaluated correct? So as A is a scalar which is independent of a summation, so I have to take it outside. So it is summation over I vi dou f by dou xi at a point P plus B summation over I wi dou f by dou xi at a point P, right? So if A is outside, what is this one? Vi dou f by dou xi and summation over I wi dou f by dou xi. Can anyone tell me this with the help of our formula 1 which we have written here? What is there in the formula 1? Summation over I vi dou f by dou xi is vpf, right? Correct. So can anyone tell me the value of these two brackets?
A into VPF plus B into WPF.
Okay, so A into vpf here, and this is what? B into wpf. Okay, summation over I wi dou f by dou xi means what? It is directional derivative function f at a point P in the direction of a tangent vector w. Okay, so this is what we have done with the help of a formula. Okay, now let us go to prove the second property. What is there in the second property? We want to prove that it is linear in f and g. So this is what your second property, a tangent vector vp, and here it is af plus bg. That is directional derivative of a function af plus bg in the direction of a tangent vector vp. Okay, so how to write this one is equal to, how to write this as summation over I vi, right? Vi as it is, then correct. यहाँ पे vp है इसलिए हमने यहाँ पे vi लिया है, right? Let me write down the formula once again here. Directional derivative function f in the direction of a tangent vector vp is summation over I vi dou f by dou xi. Okay, सो इसके हिसाब से यहाँ पे क्या होगा, वीपी सेम, यहाँ पे भी वीपी है, सो समेशन ओवर आई वी आई एज इट इज होगा। यहाँ पे फंक्शन एफ की जगह पे यहाँ पे क्या है, ए एफ प्लस बी जी, करेक्ट। इंस्टेड ऑफ हैविंग अ फंक्शन एफ वी हैव ए एफ प्लस बी जी। कैन एनीवन टेल मी व्हाट विल बी द चेंज हियर? What should I write here? One. हे dou by dou xi तर सेम असणार आहे. At a point p is also same. But instead of a function f, we have it is combination of a function, that is af plus bg. Is it okay?
Yes, ma'am.
Okay, summation over I vi as it is. Instead of a function f, we have af plus bg. Okay. Any doubt for this one? आहेत का सगळे सकाळी?
Yes, ma'am.
Again, there are only 33 students after all its instructions. Okay, so what we have to do now? So we have to separate this one. How to separate? This is AF plus BG. Just we have to separate it as summation over I BI dou by dou xi of AF. Correct? Sorry, I should not write this as a square bracket, because square bracket here we have written it is for the notation of directional derivative, plus at a point P plus summation over I Vi dou by dou xi of a bg at a point P. Right, now as A is independent of this summation, so I can take outside. This is what summation over I dou f by dou xi at a point P. Correct? Plus B, as it is outside the summation, we can write this as summation over I Vi dou g by dou xi at a point P. Okay? Now can anyone tell me what is the value of this one and this one?
VPF and VPG.
Okay, this is what A, VPF. Correct? Here you can see the formula. VPF चा हे formula है. So here we have only the change in G. Okay, as it is formula है ना ये वाला. So we can write this as B as it is. Now instead of F here we have a G. So what we can write is VPG. Directional derivative function f in the direction of a tangent vector Vp. Okay, so what is the resultant we can write here? Vp af plus bg, that is directional derivative of a combination of these two functions af plus bg in the direction of a tangent vector Vp is written as a at times directional derivative function f at a point P in the direction of a V, plus b times directional derivative function g in the direction of a tangent vector Vp. Any doubt for this one?
No, ma'am.
No,
No,
ma'am.
ma'am.
Okay. Should I go for the third property? What is there in the third property? We have to prove the multiplication. That is, if we have a multiplication of a two function, then how to evaluate the directional derivative. This is what the Lebanese rule, or we call the rule of multiplication for our derivative. What is the rule? First we have to keep g as it is, and then we have to evaluate the derivative of a first function, right? So in the very similar way of a formula, what is there in the formula? I will write once again. VPF is equal to summation over I Pi dou f by dou xi. Okay. Now instead of a function f, we have a combination of a function, or rather multiplication of a function f into g. इथे काय लिहू शकते मी मग? Summation over I Vi, right? Into dou by dou xi will also be as it is. Now instead of a function f, what we have, a multiplication of a function f into g at a point P. Be clear with these bracket. This is a square bracket. This is this is a square bracket. This is a simple bracket which we are writing, circular brackets. Okay. Now everyone know how to evaluate this partial derivative. माहिती आहे? How to evaluate summation over I Vi? Yes, can anyone tell me how to evaluate this partial derivative?
Dou f by dou xi into g plus f into dou g by dou xi.
Right. So first we have g as it is, derivative of a function f, plus next term, then we have f as it is, derivative of a function g with respect to xi, and at a point p we are evaluating. Okay. So let us now separate the summation. What we have to do, this is summation over I vi g dou f by dou xi, all evaluated at a point P, plus summation over I vi f as it is at a point P. Here also we want to write down g at a point P. Then this dou g by dou xi at a point P. Correct. Now as g of P and f of P are independent of your summation, so we can take this as outside g of P. Independent आहे ना summation वरून. Whether it is GIP, if it is GIP, then we can keep it inside the summation. Summation over I vi dou f by dou xi evaluated at a point P. So this is what we want to evaluate. Plus f of p is also independent of summation value of a function f evaluated at a point P. काय असणार आहे रिअल व्हॅल्यूड फंक्शन एका पॉइंटवर इव्हॅल्युएट केल्यावर? What is a real value of a real valued function f evaluated at any point p? What is p? P is any point in E3 space. F is a real valued function. F real valued function, suppose it is x square, evaluated at a point 1 1 1. काय असणार आहे value?
Real value.
I am asking the value of this one. X square evaluated at 1 1 1. So x square means what? 1 square, it is equal to 1. So which is nothing but a real valued function. So that's why it is written that f is a real valued function defined on a E3 space initially in our statement. Right. So this g of p as it is, what is the value of this one? Summation over I vi dou f by dou xi. From the formula itself, you can see this value is vpf, directional derivative of a function f at a point P in the direction of a tangent vector Vp, plus f at a point P, then what is the value of this is summation over I vi dou g by dou xi is Vp g, correct? And hence the result. Yes, any doubt for this one?
No, ma'am.
Okay, let us repeat what we have seen in this. Starting with the first one, what we want to do, we have to prove the properties of a directional derivative. Okay. Read these properties, and then if you have a doubt, you can ask. Yes, any doubt for these properties which we have proved just now? I hope you are writing this. लिहित आहेत का at least जे
Yes, ma'am.
important points आहेत?
Yes, ma'am.
Should we go for the next one?
Yes, ma'am.
Ma'am. Ma'am,
Yes.
VP एक आपण असं पण डिटरमाइन करू शकतो का?
VP, what you told, I just don't understand.
VP F into G आपण डिटरमाइन केलो ना आता, मग आता VP F डिवायडेड बाय G करू शकतो.
Acha, you want to say that directional derivative for division, right? Just like we have done for a multiplication. Is this a question?
Yes, ma'am.
Okay. So for that one, what we know is actually that is what I want to tell just now. While solving the example, you will come to the idea that how to evaluate about f upon g. Okay. Just now we have seen Vp f into g is nothing but this whole value. Correct. So आपको Vp f into g evaluate करने के लिए क्या निकालना पड़ेगा values? First one, you have to evaluate VPF and VPG. If you know these two values, then value of F and G at a point P, you can evaluate and you get the result. Okay. So in case of VP F upon G, we can evaluate the values. Again, you have to use the same formula. What you have to do? Summation over I, VI, dou by dou xi of F divided by G. Correct? Again, you have to use the same formula. Okay, जो हमने partial derivative के लिए F upon G का रूल है, वो आपको रूल अप्लाई करना पड़ेगा. Okay? And suppose you know the function f is equals to some x square and g is equal to some y square, then at that time it will be more easy to evaluate f upon g or f into g. Correct?
Yes, ma'am.
Is the idea clear now? What you have to do? Just use the formula summation over I vi dou by dou xi of f divided by g. Now you can evaluate this formula, that is partial derivative of this division. Okay, if you know this formula, then you can evaluate it very easy. Now here we have seen whatever we know for whatever we want in the basic ideas. Okay, is the doubt clear?
Yes, ma'am.
If yes, let us go for the next point, that is here we have evaluated the value of a directional derivative with the help of a tangent vector. Right? Now we will evaluate the directional derivative of a function in the direction of a vector field. In the direction of a vector field. Just now we have evaluated this on a tangent vector, but here we will evaluate now directional derivative function f in the direction of a vector field. Okay. Here we have evaluated VPF. What is VP? Here it is VP is a tangent vector. Now we want to evaluate the directional derivative function f in the direction of a vector field. Okay. Now everyone know what is a vector field. Should I go for the definition? Vector field is what? A collection of all the tangent vector once at every point of a E3 space. Correct? And we have seen very specified vector field as all the tangent vector going in x direction, all the tangent vector going in the y direction, all the tangent vector going in the z direction. Correct? Or rather, we have seen the real one, that is gravitational vector field. Next, we have seen the magnetic field, जहाँ पे हम एक मैग्नेट रखते हैं और सभी पिंस उसके उसके पास अट्रैक्ट होते हैं, right? So it has some amount of field. Suppose here is a magnet, it has some field created here, right? जहाँ if you put any pin here, it will be attracted here, correct? So here also, what is a vector field? Vector field V is a function. If you remember, it is defined from some domain and codomain. Can anyone remember what is a domain and codomain for the vector field?
E3 to union of TP E3.
E3 to union TP of a E3. Why we have written E3 initially in the domain? Because we have defined everything on the E3 space, right? Because what we say for the definition of our vector field, at every point P of a E3. That means the domain is fixed out E3. At every point P of a E3 space, there exists one tangent vector. So where the tangent vector actually exists in the TP of E3. Now everyone know what is a TP of E3? It is a tangent space. Okay, at every point of a your E3 space, you can find out one tangent space, and this tangent space is called a vector space because it satisfies the all the properties of a vector space with the help of a vector addition and scalar multiplication. Okay, so the that's why I remind you what is a field. Okay, now everyone know field. So now we want to define or we want to find out the directional derivative of a function f in the direction of a vector field. For that, as I told you that if you want to find out the directional derivative, or if suppose I have this vector field arbitrary one. Okay, if I go to a point, what I get? Yes, can anyone tell me if I go to any point in the E3 space in a vector field, what I get? काय दिसतंय इथे तुम्हाला? If at every point what you are getting? काय आहे ते? Tangent vector आहेत ना?
Yes.
Yes, everyone able to hear me?
Yes,
येतंय
ma'am.
का असं? असं कधी कधी वाटतंय काय क्वेश्चन विचारल्यावर काय आवाज येतंय का नाही? You should respond. Okay. So at every point, if I go to any point in the E3 space, okay. If I go to any point in the E3 space in your vector field, what I get one tangent vector, right? So if you go to any point in the E3 space, आपको क्या मिलेगा वहाँ पे एक tangent vector definitely मिलेगा, correct?
Yes.
Okay. So if I want to find out the directional derivative function on the whole the vector field, now you should have a sufficient difference in that VP and वेक्टर फील्ड v. यहाँ पे आपको स्मॉल v यूज करना है, यहाँ पे कैपिटल V वेक्टर फील्ड के लिए, और ये tangent वेक्टर. एंड दिस v of p means what on the vector field. और पूरे वेक्टर फील्ड में जाने के बाद, right? If I go in a whole vector field, if I go to a point, what I get? हाँ, answer me. Try to have a discussion session, otherwise it will not be very fruitful discussion, and every time you will again face the same problem in the oral and practical session seminars. Okay, because if you go out after passing the MSc, everyone will ask you some basic question. If you are not going to answer it, and if you are not able to discuss with the people, then they will ask who are your teachers, from where you have completed your MSc. So just have a discussion session. Every lecture I am asking you to have a discussion session. MSc का मीनिंग ये होता है पोस्ट ग्रेजुएशन. इन द अर्लियर डेज इट वाज जैसे हम लोग आपको पढ़ाते हैं और सब नोट्स देते हैं. नोट्स देना भी कंपल्सन नहीं है एट द पीजी लेवल, राइट? ओनली guidance is there in at the PG level, and you have to prepare your own notes. So that's why if you want to prepare your own notes, you should be having a discussion with your friends, with your uh, maybe you, with your colleagues, and that means your senior, that's like those who have passed out or those who are senior. Then after doing that discussion itself, then you can prepare your own notes, which gives you the idea that how to do a research, right? जब तक आप खुद के नोट्स नहीं बनाओगे, रेडीमेड नोट्स यूज करोगे, तो आपको आइडिया नहीं होगा कि आप नोट्स कैसे बनाओगे. और जब तक आप डिस्कशन नहीं करोगे, आपको नहीं समझ में आएगा कि how to do a healthy discussions. Okay, so every time whenever I ask a question, please don't allow me to repeat the question and again go back to our meet whether I am able to uh, under whether everyone able to hear me. Okay, I have to speak this every time in the lecture many times, right? Whenever I ask you the question, no one is responding. Then again, I have from this journal to I have to go to this Google Meet, and then I have to check whether I am in the meeting or not. Okay. This is what we have to evaluate the directional derivative function f in on the whole vector field. So again, the same question is there. On the whole vector field, you cannot do anything directly on whole vector field. So on the whole vector field means what? There are so many tangent vector at every point on the E3 space. So to evaluate anything on a vector field, that means I have to go to point wise. Okay, at every point I have to go, and if I go to a point in the vector field, I get a one tangent vector, right? So here also we have to do the same thing. If I want to evaluate the directional derivative on a whole vector field, that means I have to go by a point wise application. What is this point P? This is a point P in a E3 space. Okay. So this whole vector field means what? At every point P of a E3 space, I can get one tangent vector. So directional derivative function f on a vector field can be written as VPF. Now this VPF ensures that this is a vector, tangent vector in your given vector field. VPF is equal to, now this has been reduced to our original definition. What is our original definition? Which we have seen is VPF is equal to summation over I bi dou f by dou xi. So hence which is equal to summation over I pi dou fy dou xi, correct? Because what is the question here? You have to evaluate the value of a directional derivative of function f on whole vector field. Evaluating on a whole vector field at a time is not possible because there are infinitely many number of points in a E3 space. So I have to go by a point-wise application. If I go to this point, so I get one tangent vector. Now the definition of a whole vector field has been now reduced to the directional derivative of a function f on a tangent vector, and this definition already we know. But what is the change here? If you change the point P, obviously your tangent vector is going to change. Understood the definition of a directional derivative of a function on a vector field?
Yes, ma'am.
Okay, so this is what the definition, that directional derivative from function f with respect to a vector field is defined as a directional derivative of a tangent vector Vp, right? That means here we want to say that we are applying a point-wise definition. That means if you change a point-wise definition, अगर आप point P change करोगे तो आपका tangent vector change होगा, correct? Now let me go for the another statement. That means here we want to prove the what is the effect on a particular vector field. Just like here we have seen there are some particular vector field, that is u1, u2, u3. That means if suppose we have a common direction, that is all the vector, if they are going in the x direction, then it is a u1 vector field. If all the vectors are going in y direction, then it is u2 vector field. If all the vectors are going in z direction, then it is u3 vector field. Correct? So let us go for the statement. What is there in the statement? We have to write if u1, u2, u3 are the natural frame field at a point P, then show that. Okay, we have u1, u2, u3 are natural frame fields at a point P, then show that. What is our aim to show that? u1 f, that is directional derivative function f in the direction of a u1 is equal to dou f by dou xi or dou f by dou x1. In the very similar way, we have to prove that directional derivative of a function f in the u2 direction is dou f by dou x2. In the very similar way, directional derivative function f in the u3 direction is equal to dou f by dou x3. Correct? So here this theorem is very important to show that your directional derivative is reduced to partial derivative if you are finding in the particular directions. Okay. Okay, here what is the question? If you are finding in the particular direction means what? If you are finding the directional derivative in the x direction, then it is a dou f by dou x1, right? If you are finding the directional derivative in the y direction, then it is dou f by dou x2, or you can write this as dou f by dou y, right? Here directional derivative function f in the direction of a z axis or u3 is written as dou f by dou x3, or I can write this as dou f by dou z, correct? That means this theorem is telling you that if you are finding a directional derivative in the particular direction, that is what the main property of a directional derivative, the name itself suggests directional derivative. That means you are finding the derivative function in arbitrary direction, but that arbitrary direction we have fixed out now. What is a fixed out direction here? It is u1 u2 and u3. अगर हम u1 u2 u3 fix कर रहे means what? We are finding derivative in either x y or z direction, and hence it is reduced to a partial derivative. Okay. In the very similar way, we have proved one theorem initially in the lecture, that our derivative, directional derivative is summation over I vi dou f by dou xi. What do you mean by this theorem? At that time, I told you that this directional derivative is nothing but the linear combinations of the partial derivative. आठवते का सगळ्यांना?
Yes, ma'am.
Yes, ma'am.
So directional derivative is nothing but the linear combinations of partial derivative. But इस linear combination में हमने क्या fixed out किया है? Instead of having any arbitrary direction bi, if I am fixing the direction that is either x or y or z. या तो आपको x direction में find करना है या y या z direction में, right? So if you are finding either x, y or z direction, that directional derivative is now reduced to a partial derivative. Any doubt for this one? Whatever we have statement here, and then we will go for the proof. Yes, this dou f by dou xi ensures that these are partial derivative. This is dou f by dou x1 means f with respect to x, f with respect to y, and f with respect to z. And this notation dou is a notation for partial derivative. So here this theorem ensures that directional derivative reduces to partial derivative if you are finding in either x, y or z direction. Let me evaluate this now, the first one. That means what I have to evaluate is, firstly we will write the definition. Directional derivative of a function f on whole vector field. Again I am saying the same thing. What is the question? That is vector field is there. Okay, vector field means what? At every point I am finding one tangent vector. Okay, what is a vector field? It is a function defined on E3 space to union TP of a E3. You should know what is TP of E3. Tangent space. Tangent space means what? एक पॉइंट लेना है आपको E3 स्पेस में, उसको लेके उसको एज अ पॉइंट ऑफ एप्लीकेशन आपको मेनी tangent vectors डिफाइन करना है, right? So, and if you go on a vector field, you cannot evaluate directly on whole vector field. So what you have to do, you have to go to a point-wise application. Okay. So if you go for point of application, then you will get one tangent vector. Now the definition is reduced. Okay. This definition we know, which is equal to summation over of I dou f by dou xi at a point P. Any doubt for this one?
No,
Okay, so let us now evaluate the question which is provided to us. U1P ISL, it is 100 at a point P, which is equal to, I can write this 1 is nothing but your V1P, and what is 0? This is what your V2 of P, and this is V3 of P. Okay. So now if I want to evaluate the directional derivative function f in the direction of a u1 vector field, again I have to go by a point wise application. सगळ्यांना point wise application कळालं का?
Yes, ma'am.
Okay. So what you have to do, u1 at a point P, in the direction of directional derivative function f in the direction of a u1p in the very similar way of here. Okay, just have a similarity. Okay, which is equal to what I can write now here, summation over I vi dou f by dou xi. Now what are the vi? We know the values of vi here. v1 is 1, v2 is 0, v3 is 0. Correct? So what will be the value if I evaluate this summation? This is what v1 dou f by dou x 1 plus v2 dou f by dou x2 plus v3 dou f by dou x3 evaluated all this at a point P, because this is what we are doing this with the point wise application. Okay, directional derivative function f on a whole vector field is now reduced to a u1 at a point. Now v1 value of v1p we are knowing, that is 1, all others are 0, so this will be 0, this is also 0. Is it correct?
Yes, ma'am.
Yes, ma'am.
So what I get is simply value of v1 is 1, 1 into dou f by dou x1, which means that the u1 f at a point P is nothing but dou f by dou x1 at a point P. Now as P is an arbitrary point in the E3 space, and hence we can generalize the concept u1f is equal to dou f by dou x1. That means the value of a directional derivative evaluated in the x direction is our partial derivative in the x direction. Any doubt for this one? What you have done? We have done a very simple calculation. If you know the definition of a vector field on directional derivative on a vector field is evaluated by point-wise application. So instead of vector field B, arbitrary vector field की जगह पे हमारे यहाँ पे U1 है. Okay. So U1 you have to write it as 100. So first is V1, second is V2, third is V3. Correct? And then just you use the formula and you will get the result. Second and third will be 0, and the first one p1p is 1, and hence the result, as p is arbitrary point in the E3 space, so hence the result. Okay, so you can say that similarly we can prove for u2 u3. Can you prove this? काय change असेल u2 u3 साठी? Yes, can you tell me what is the change for u2 and u3?
Partial differentiation with respect to x2 and with respect to x3.
Okay. Can you do it, everyone?
Yes, ma'am.
Okay. Ma'am. So see, I have to be a strict for you people, because you are not responding for the lectures. The presentee is also less. So don't assume that madam has become very strict now, because it is the situation now for you people, because I don't know for how many days you have to attend the online lectures. Okay. So don't feel that we are doing very strict rules and all. This is for you people, not for us. So just have a discussion session in every lecture, so that it will be useful for you people. Okay, because हमारा MSc, हमारा setnet सभी हो गया है. So it will be easy for you people to face the challenges of our life after completion of MSc. आप एक just क्या बोलते हैं, एक एग में हो, और जब एमएससी पास आउट करोगे तो वो एग में से बाहर निकलोगे, तब आपको पता चलेगा कि व्हाट इज द एक्चुअल रियलिटी. सो यू शुड just treat everyone with the help of your knowledge. So just be knowledgeable, have discussion sessions, because जिस जो बोलता है उसका ही बिकता है ना. I hope you are knowing the story of Dhirubhai Ambani. Hello.
No, ma'am.
Just you should read the stories of the great people who have done some great things in their life, right? Elon Musk, then Bill Gates, then there are Dhirubhai Ambani, Anil Ambani, Mukesh Ambani. मुकेश अंबानी इज अ गुड एग्जाम्पल फॉर एवरीवन कि बहुत ज़्यादा पैसा होने की वजह से हम लोग बहुत ज़्यादा अमीर नहीं बन जाते. So we should invest the things in a particular direction, then only we can get earnings. Okay. So we feel sometimes we feel no कि we should हम बहुत ऐसे वेल टू डू फैमिली में होना चाहिए था, बिग एंड रिच फैमिली में. But you can see the example of Mukesh Ambani. He got much amount of things than his brother Anil Ambani. But what is the result now? And you know many of the people's. I hope everyone knowing the BTS. कुछ तो नाम है ना उसका. यूट्यूब पे बहुत फेमस है ना, वो डांस का एक टीम है.
Yes, ma'am.
व्हाट इज द नेम? BTS ही है ना.
Yes, ma'am.
I don't know how many of you people know that what is the practice done by these people, because if you read their biography or if you go to their institute, you can see how what amount of a practice they are doing. They are registered as a student in that particular company, and after registration as a student उस कंपनी ने उनको सभी प्रोवाइड करता है कि dancing, singing, everything they teach those student, but with the help of one contract that with उस कॉन्ट्रैक्ट में लिखा होता है कि आप जब सक्सेसफुल बनोगे तो आपको 80% उस कंपनी को रिटर्न करना है, जो भी आप प्रॉफिट कमाओगे, राइट. So we feel that they are so lucky, they are so famous and all, but they उनका जब आप as a student जब उन्होंने रजिस्टर किया था, तो आप चेक कर सकते हो on the website itself. They prepare the group of students, and only one group among them is going to be selected, and then with the help of that group only they are going to earn. Okay, उस कंपनी के कुछ रूल्स होते हैं. So after becoming very famous, they have to give 80% of their earning to that company, क्योंकि उस कंपनी ने उनको वो सब सिखाया है जब वो बहुत छोटे थे. As a student they have registered. Okay, and they are having so many criterias that they can't eat with their own लाइफस्टाइल. जो भी हम खाते पीते हैं वो भी उनको वो कंपनी ने जो दिया है उसी में खाना पीना पड़ता है, और उनको कोई रूम वगैरह भी नहीं प्रोवाइड करता है. आफ्टर बिकमिंग फेमस दे गिव अ गुड ट्रीटमेंट फॉर दीज पीपल, बट जब तक आप ग्रुपिंग में होते हो उनको कोई अच्छा ट्रीटमेंट नहीं मिलता है. इवन दे वहाँ पे एक रूम में भी सिर्फ एक ही रूम होता है उनको सोने के लिए, पूरा एक ग्रुप के लिए, राइट. So these type of struggles we have to do if you want to be a famous person.